Then what is problem solving? It is a task of expressing the solution for the complex problem in terms of simple operation which must be understood by the computer system. When it comes to the algorithm, it is a step-by-step procedure in order to solve a given problem. The stages of an algorithm must be definite, and each line of a code, it must be clearly specify that what should be done. Hello everyone, welcome to the new chapter 5, that is problem solving methodology. Myself Rohini TS, lecturer in computer science, Vidhyaashram Pre-University College, Mysuru. So before getting into the objective of this chapter, let me have a blueprint. So if you study this chapter, so you are going to get totally 11 marks. Then how will be the marks distribution? We'll see now. So when it comes to the 1 mark question, you are going to get one question from the 1 mark. When it comes to the 2 mark question, then you are going to get one question for the 2 marks. Then when it comes to the 3 marks, then 3 marks, one question will be there. For 5 mark question, you are going to get one question from the 5 mark. So totally you are going to get 11 marks from this chapter. So very high weighted chapter. You have to be very conscious regarding all the topic of this chapter. That is 1 mark, one question will be there, 2 mark, one question, 3 mark, one question, 5 mark, one question. So in all the part, you are going to get one question each from the chapter. So what is problem? How to solve the problem? What are all the methodologies that we are going to use? That are all the objectives of this chapter. What do you mean by problem? How to solve a problem? And what are the methodologies that we are going to use? And what are the coding part will going to happen? Everything that we are going to study in this chapter. So in this chapter, in this session, I will be discussing the introduction of problem solving methodology. Along with that, we're going to have a look regarding what are the steps that involved in problem solving. So if you just recall the applications of a computer, so where we are going to use the computer, what are all the fields? So can we use the computer only for a particular purpose? No. So computers are mainly used and manufactured in order to solve more than one kind of problem, isn't it? We are going to use the computer in order to play the games, in order to listen to the music, in order to get done our work, right? So for all those purposes, we are going to use the computer system. So can I call a computer as an electronic brain? Yes, you can, but that is a wrong assumption. So without any instruction, computer is a dumb machine, right? So we are supposed to give the instruction, based on that instruction only, computer will going to work. So that means we have several problems. That means we have a complex problem and we need to get done the work by the computers. So computers are mainly used to solve the complex problem. Why it is difficult for the human? If it is simple and finite number of steps, then that will be easier for the human beings. But what if includes infinite number of steps, whether it includes any of the complex stages, at the time computer will going to help us, right? So computer is not an electronic brain. It is a dumb machine, but we have to give some instruction to the computer, then it will going to take that instruction and then it process and it will going to give the desired output. So this is how the computer will going to work. So when it comes to the problem solving methodology, instead of considering a problem as a complex task, we are supposed to divide the problem into number of sub-problem. Okay, then computer will going to intimate or computer will going to process each of the sub-problem individually or separately, and it will going to give a solution for the complex one. In that moment, what it will going to do? So problem solving methodology, in the sense, we are going to find a solution for a problem step by step, or we are going to making the complex problem into number of sub-problem. Then we are going to find a solution for each sub-problem, and whatever the solution that we are going to get for each sub-problem will be get integrated together in order to get a answer or a solution for the main one. For example, here I have a complex problem. So what I am going to do? I am going to divide this problem into number of sub-problem. Then I am going to find a solution for each sub-problem. So what I got now? I got a solution for all the sub-problem. Then I am going to integrate all these solution in order to get a solution for the complex problem. So that means we are not supposed to take the problem as a complex task. It must be divided into number of sub-problem. So that is what they are going to tell in the problem solving methodology. So we have to analyze the problem and what are all the stages it includes, what are all the methodologies that we want to takes place, everything I am going to discuss in this session. So now we'll see what is problem solving methodology, what are all the stages that we need to follow. So when it comes to the problem solving methodology, whether a problem is restricted to any of a particular field, no. So problem is everywhere. We have to find the solution. So that means what? Problem is many disciplines. The term problem solving is used in many disciplines so that it is not restricted to a particular place or a field. So problem is everywhere so that we need to find the solution in a different manner. But at last we have to find a solution for our problem. So that is what they are saying, that sometimes with different perspectives and different terminologies. I am going to define some problem in my terminologies or in my perception. Someone will going to take that problem as a easy task. They are easily going to find the solution for that problem. So that problem solving in the sense, it will differ with regards to the perspectives, with regards to the different terminologies. So the problem solving process starts with the problem specification. What we want to do first we have to specify the problem. What is the problem? Then only we are going to find the solution, right? So without knowing the problem, can we find a solution? That is impossible. So that first we need to specify the problem. That is the first stage, and that must end with a correct program or a output. First, we need to specify the problem, what is the problem and what are all the methodologies that we are supposed to follow, and at last we are going to end with a proper output or a correct program. Then what you mean by problem solving methodology? Important for 1 mark question, that is the task of expressing the solution of a complex problem in terms of simple operation which is understood by the computer. Can I do the process which is understood by me? It has to be understood to the computer system. Then only computer will going to process that data and it will going to give the desired solution. Then the problem solving methodology or a problem solving is nothing but it is a solution or expressing the solution or finding the solution to a complex problem. We are not going to use a computer for only complex problem or to any simple problem. So it has to undergo all the types of problem. Then what is problem solving? It is a task of expressing the solution for the complex problem in terms of simple operation which must be understood by the computer system. Okay, this is what about problem solving. What do you mean by problem? How to solve a problem? So as I discussed here, so we should not take a problem as a complex task. It must be divided into number of simple operations so that must be understood by the computer. If it is understood by the computer, then it will going to find a solution for us. So that is the thing that you have to remember. Then what are the stages we have in order to solve a problem? What are the steps that we need to follow while we are going to get a solution for the problem? So here you are seeing that we have several stages or steps that needs to be followed one by one. So the steps which needs to be followed in problem solving methodology, very important question. What is problem solving methodology? Explain the stages. So at that time you have to write a definition and all the stages you have to explain. Then which is the first step or a first stage? That is problem definition. So in problem definition, we are going to define the problem. What is the problem and all. So next we have a problem analysis. So I need to analyze the problem, why this problem occurs and what are the methods that I am going to use. That and all we are going to discuss in problem analysis. Then, so design a solution using a design tools. So then what are the design tools I am going to use? That is flowchart and algorithm. Okay, so first we need to define the problem and we need to analyze the problem. Then we need to write a designing tools. That means we have to design a solution by making use of the designing tools called either flowchart or an algorithm. Then coding. So once we are done with analysis or once we draw that flowchart or algorithm, then we have to write a program. So writing a program is nothing but coding. So you may heard a word called programming or a coding. So there what we are going to write? We are going to write a program. That means we are writing the instruction to the computer system in order to get done our work. So that is coding. Next we have a testing and debugging. Checking and correcting of the errors. So that means what? I have written a program and I am going to check whether what I have written that is true or false, whether it is correct or not. So there I am going to check if there any errors occur, then we are going to debug. So that is testing and debugging. So now all finished with all these steps. Then what is the thing? I have to document. So what is the problem and how to analyze that problem and what are all the design tools that I have used. Then I have written a program, then I have checked that program, yes it is working fine, then that has to be documented. So why the documentation is necessary and for what purpose we are going to document. So that will be important. That is documentation. So the last stage is program enhancement or a maintenance. So I am done with the program. But now I am feeling that, so if that would be the one more thing, then it look fine. So at the time what I am going to do, I am going to upgrade the existing program. That is program enhancement or a maintenance. Maintenance in the sense, it will going to keep track of its working procedure. If there any enhancement or any upgradation is required, then it will going to happen in this stage. So what are the stages we have in order to solve a problem, or what are the stages we have under the problem solving process? So totally we have 7 stages. So let me brief it out. Problem definition and problem analysis. After that we are going to design a solution with the help of designing tools. That tools are either algorithm or a flow chart. Then coding, that is programming the algorithm and flow chart. Then testing and debugging, that is checking and correcting of an errors. Then documentation, program documentation. Then program enhancement or a maintenance. So now we'll see the first stage or a first step of a problem solving process. Which is the first step? That is problem definition. So the problem definition is the first step of a first stage of a problem solving process. So can we find an answer without knowing the problem? That will be difficult, right? So if I am doing something without knowing that, then that is waste of time and energy. So if I am trying to solve a problem, if I am giving that as a problem, at that time user must know that what is the problem rather than how it will be solved. So what is the first step? That is problem definition. We have to define the problem. What is the problem? Then later on we are going to think about its methodology. How to solve a problem? What are the causes of this problem? That will be secondary. Okay. So in a first stage or a problem definition, I must understand that what is the problem. So how it will be implemented, how it will be solved, everything comes later. When it comes to the definition, we must be guaranteed that yes, this is a problem. I need to find a solution for this problem. Okay. So the steps defines that problem thoroughly. So we have to understand the problem thoroughly. Then only we are going to find a solution for that problem. So here we are going to specify the requirement. So in this first stage, we have to understand the exact specification of a problem. That is, exact specification is very, very important. So without specifying what is problem, we are not able to find the solution for that problem. So that problem definition includes, it must specify or it has to define the problem thoroughly. Okay. So in this stage, user must understand that what is the problem rather than how it will be solved. So that is the first stage, that is problem definition. So in these steps, it includes understanding the problem very well. I must understand the problem very well. Then I can move to the next stages. So the problem solver, that means the user or a designer who is solving that problem, they have to be very careful and they have to be very clear that yes, this is a problem. So I need to find a solution for this problem. Okay. So let me take one example in order to illustrate the problem definition. Okay, I have a set of several visiting cards. So I want to find a particular visiting card which is associated with person name and his mobile number along with the address. Okay, so I am going to give you 10 or 5 visiting cards. So when it comes to the problem definition, I have to specify that I'm searching for a particular person name along with its address and phone number. So if I give 5 visiting card, what you are going to do? First stage, what you are going to do? You are going to search. For example, I'm searching for the person XYZ and his number is something up to 10 numbers. Okay, so I'm searching for the person XYZ and I'm seeking for his phone number and what? Address. Right? So that is my problem. So I'm going to give you 5 visiting cards. So at that time, what you are going to do? So you are going to randomly check which visiting card has its name along with a phone number. But whether I'm specifying, if the visiting card does not contain any number or any name, then that will be the problem. And one more question is there, whether the visiting card has been arranged in a ordered or whether it is in the random manner. For example, here I am checking for XYZ. So now it is for 5, then that will be fine. What if it has 500 number of visiting card? At the time, you are going to check whether it is randomly arranged or sequential order. That means whether it is following the alphabetical order. So that you are going to find or you are going to specify it properly. It is arranged sequentially or alphabetically so that you can go one by one. So if it is alphabet, I am going to leave all the things and I will directly move to X letter. Getting? So this is what the problem specification or a problem definition. Here I am not specifying whether it is arranged randomly or a alphabetical order, and I'm not giving any hint. That means you have to follow this method or that method. I'm not at all specifying anything. So I'm just specifying or defining the problem. That means I want a visiting card of a particular person and it must contain its phone number along with the address. So this is my problem definition. Okay. So in definition, I have to specify the problem thoroughly. So here I am not specifying what if the person name is not there. So that will be the another thing. So the problem definition must be very clear. So who is going to solve the problem? That is a problem solver must be very clear that if it is the thing, it must be the problem. Okay. So this stage will going to define or specify the problem. We'll move on to the next stage, that is problem analysis. Analysis in the sense what? We are going to analyze the methods. So why this problem occurs and how to solve this method and what are all the input and output it will going to give and what are the methods that I am going to use. Everything comes under this problem analysis, right? So analyzing the problem or analysis involves identification of the following things. So if I am analyzing the problem in the sense, I have to analyze what is the problem. In first stage, I have defined the problem. That is problem definition. Now I know exactly what is the problem. In problem analysis, I am going to analyze what are the input and output I require. So what must be the input? What must be the output? What are the methods that I am going to implement? Everything comes under this second stage, that is problem analysis. So here, first point is input. So that is the data you have to work on with. So now, what was my example in the previous stage? That is, I have to find a visiting card of a particular person along with his name and address. So that was my problem. So then what is the input for that one? I have to specify the visiting card. All the visiting cards should contain name, address and phone number. Then I can say that it has a proper input. So if any one of the visiting card does not contain name or address, then that will lead to an error, right? So that it has to be specified properly. When analyzing things, I have to understand what is the input, what must be the data it has to be given in order to solve that problem. So that is the data. So as I discussed earlier, data can be anything. So it could be either text, numbers or an image, audio, video. It could be any of the data. In order to solve a problem, the data is important. So then it will going to take the data as an input, then it will process, then it will lead to a proper output. So that the data that you have to work on it must be important. Then output. So if I am giving this input, then what will be the output that I have to analyze? So that comes under problem analysis. That is outputs the desired result. So now what I'm checking for? So I'm going to give the input as a person name and his address along with a phone number. That is the input. What is my problem? I have a person name called XYZ. I want to find his visiting card along with its address and phone number. That is my problem that I have defined in the stage 1. So when it comes to the stage 2, that is analysis. So here I am going to check whether it contains all the data. That means whether it is arranged in a sequential order or alphabetic, or whether all the visiting card have been put as a random manner. That I am going to check. So if it is in a alphabetical order, then that will be fine. If not, then how must be the data? It has to be arranged in a order, that is alphabetical order. Then that will be easy for me. Then what is the input that I am expecting? I am searching for a particular person's visiting card. So that will be the output or a desired result. So in analysis, I am going to check what are the inputs that I am giving. So out of that input, what will be the output that I am going to receive. So these are the stages that you have to understand when it comes to the problem analysis. So now I am done with input and output. After that, if there any upgradation is required, so now I am okay with person's name, address and phone number. But along with that, I want to have one more features. At that time, what I am going to do? I am going to analyze. So it includes its email or any social media account link. Then that will be more helpful. Okay, so that any additional requirements on the solution. So at the time, what we are going to do? So we are going to add any other additional features or additional requirement which is required in order to solve a problem or in order to find a solution. Okay, so when it comes to the analysis, here everything is like WH question. So what is the input? What is the output? What are the methodologies that we are going to use? How we are going to implement? And when it will be produced. So these are the questions that must comes to the problem solver when they are analyzing the problem. That is problem analysis. I hope you got stage 1 and stage 2. So this stage is the first step that leads to the solution. Okay. So in first step, I have just defined that I have specified what is the problem. But when it comes to the problem analysis, here I am going to analyze its input and what are the methods that I am going to use and how it will be the output. Everything I am going to analyze so that it will be the first step in order towards the solution. Okay. So this is regarding problem analysis. Then which is the next stage? That is designing of a solution by making use of designing tools. So what are the designing tools that I have? That is algorithm and a flow chart. Algorithm, then we have a flow chart. So now I know what is the problem and I know what must be the input, what are the methods that I am supposed to take and what must be the desired result or a output. Then how to design a solution for that problem. So that is with the help of designing tools called algorithm and flow chart. In this session, we'll see what you mean by algorithm, what are its characteristics, how it will going to work. So when it comes to an algorithm, it is very important question. What is an algorithm? What are its characteristics? Okay, that is so important. When it comes to the algorithm definition, it is a step-by-step procedure to solve a given problem. What it is? It is a step-by-step procedure in order to solve a given problem. So we are all doing all these stages mainly in order to solve a problem, right? So mainly in order to find a solution for the problem. When it comes to the designing tools, there we have flowchart and algorithms. When it comes to the algorithm, it is a step-by-step procedure in order to solve a given problem. So here we are not jumbling or we are not doing any of the random things. So what we are doing here, we are solving a problem step by step. So instead of taking it as a complex problem, I am going to divide that as a simple operation. So I am going to get a solution in a simpler manner. That is, it is a process or it is a step-by-step procedure in order to solve a given problem. Okay, that is regarding the definition of an algorithm. Then how this algorithm word derived, so where it comes from, that is the word algorithm originates from the word algorithm. That means what? It is a process of doing arithmetic with Arabic numerals. Why it is saying that it is a process of doing arithmetic with Arabic numerals? Because it is invented by a Arab mathematician. His name is This algorithm was been invented by a person called Al-Khwarizmi in the 9th century. Okay, so he is an Arab mathematician. This algorithm is derived from his name. So that is what the reason we are going to say an algorithm which is derived from or originated from a word called algorithm. So now we'll see what are the characteristics of algorithm we have. So very important question. What are the characteristics of an algorithm? So when it comes to the algorithm, we know that it is a step-by-step procedure in order to solve a problem, right? So then what are the characteristics includes? So here we have to concentrate on the 5 characteristics. Okay, so it is a well-defined algorithm has the 5 basic characteristics. So how many number of characteristics it must follow? At least it must include 5 characteristics. So now we'll see one by one. When it comes to the first characteristics, input. So can I get the solution without giving the problem? No. So then there must be input, right? So when it comes to the first characteristics of an algorithm, it has to lead or it has to take one or more input from the user. Then it will going to process that data or information that we have given as an input. Then it will lead to the desired output, right? So input is nothing but an algorithm starts with procedural steps to accept input data. So input in the sense what? We have to give some data as the input. Then it will going to lead to a solution, right? The algorithm must accept one or more data to be processed. So what must be the input here? The data must be the input. It has to accept at least one or more input. So that is the first characteristics. We have to give either one or more input. So if I consider the previous example, that is a visiting card. So what are all the input that I have taken? I have taken person name and phone number along with the address. So whether I am giving a single input here? No. That means one or more input. It will going to take either one or more inputs. That is what is input. So algorithm must accept at least one or more data which is to be processed. Then what is the next one? That is, it must be definite. So can I do it as a infinite stages or a infinite step in order to lead a solution for the problem? That should not be the case. So it must have a definite number of stages or a steps. So each operational step or a operation must be definite. That means there must be some restriction over the number of stages or a number of steps, right? So that is definite. So each and every instruction must be clearly specify that what should be done. So that means what? Here each sentence or each line of code of an algorithm must be definite. It has to lead to some meaning. That means we have to specify in each stages or in each step we have to specify that clearly what should be done. That is definite. For example, if I am going to search for the visiting card, it should be like definite. So once it found the match, then it has to stop the searching. So otherwise what it will going to happen? It will going to search until the last one. So if does not found the match, then it has to return the value like there is no match. So then that must be the definite thing. It should not be infinite. It should be definite. That is the second characteristics. The algorithm should be a definite. The stages of an algorithm must be definite. And each line of a code, it must be clearly specify that what should be done. What is the next stage or next characteristics that we have in an algorithm? That is effective. As the name indicate, effective in the sense each line of an algorithm should lead or it must include a effective answers or a desired output. For example, it must be like trial and error. So what is trial and error? I am going to write some code. If it is working fine for my problem, then I am going to adopt that. So if the written code or a written algorithm is not working fine, then I am going to search for some new thing with related to solve a problem. So it must be effective in the sense we have to carry out the papers and pen. We have to do trial and error method. Then we are going to get the desired output in an effective manner. So if I am writing a solution in order to solve a problem in some manners, so we should not think that it is the ultimate thing. So there could be more than one way in order to solve a problem. So effective in the sense, so whatever the effective manners or whatever the effective stages which comes under the algorithm can best match with your problem, that we have to select. So that means what? It has to carry it out. At least in the principle, it must carry out by a person with paper and pencil in a minimum number of times. So as I said, it must be trial and error. So if the written algorithm is fine for our problem solution, then we can take. Otherwise, it must be very effective and it must lead to an exact solution or a result. That is the third one, or a effective. Then which is the next stage or a next characteristics of an algorithm? That it terminate. So terminate in the sense there must be some end. So when I consider that example visiting card, when it will be the end? So if there is 500 numbers of visiting card, I am searching for a particular person, its number, name along with address, right? So if I found a match at the time, it has to terminate. So whatever the left out visiting card is there, I am not going to check because I got a match, right? So I'm searching for a particular person, then I found a match, then no need to worry about the remaining visiting cards. That means there must be some termination or there must be an end to a particular stage. So if that is not the thing, what it will going to happen? I'm going to search until the last visiting card. So if I found a match, then I'm going to write an answer or as result as I found a match as a visiting card. So if not, I'm going to state that the visiting card is not present. So it has to terminate in a particular stage. So that means after some minimum number of operation, the algorithm must come to an end. So there must be an end. It should not be infinite or it should not be over jumbled. So it must has an end. So that is the termination. Then now I have taken the input, I have received the effectiveness of an algorithm and we have taken a definite number of stages and all. So what must be the last characteristic? It has to lead to a proper output or a proper result, that is output. An algorithm is written in order to solve a problem. Therefore, it must produce one or more computed result or answer, that I can call that as a output. So why are writing this problem or why we are writing this algorithm? Mainly in order to get a solution. Okay. So that solution is known as output. Okay. So once we are done with number of stages of processing and all, at last it must lead to a result. That is, we can call that as a output. If I consider the visiting card problem, then what will be the desired output? Whether it is found a match or not. So that will be the output, right? So if I am writing an algorithm, it must have all these characteristics. That is, it should be well defined. Input, we have to give one or more input and the number of stages must be definite and it must be effective in order to solve a problem, and at particular stage it has to terminate, then it has to lead to a particular output or a resultant. If I summarize all these things, algorithm is nothing but it is a step-by-step procedure in order to solve a problem. Right? So each line of an algorithm should perform at least a single task. So what it must follow? It must perform at least a single task. Then what is no ambiguity? What is this ambiguity? There should not be no confusions. So what is the main characteristics? There should be no ambiguity or there should be no confusions. So it has to be clearly defined. That is no ambiguity. So the number of stages must be finite. It should not be infinite. If it is infinite, then it will goes on, right? So we are not going to get a desired output. So the number of stages or a number of steps that I am going to write in an algorithm must be finite. Then it has to include simple statement and a structure. It should not be so complex. So if it is so complex, then it will take more time and it will lead to the errors. So it must be simple and it has to be well-defined structure. Then unique solution. So why we are writing an algorithm? I am designing an algorithm in order to solve a problem. So at last, what must be the last thing? It has to lead to a unique solution. Unique solution in the sense what? It has to give me the desired output, that which is unique solution. And one more characteristics the algorithm should include, that is capability to handle unexpected situations. So then what is this unexpected situation? That means, for example, now I am going to give some number which is divided by 0. So algorithm should be very clever that whatever the number that I am giving, if it is divided by 0, at last we are going to get 0. So these are the unexpected situations or an undesired situation. Then this algorithm must be capable of handling all these things. Okay, I hope you understood with today's session. In my next session, I will be discussing designing of an algorithm. So in this class, I have discussed what is algorithm, what are the characteristics it has. In next class or in a next session, we're going to see how the algorithm will be designed, what are the steps that we need to follow, and what are the advantages it includes, what are the disadvantages, and how it will be designed. Everything I'm going to discuss in the next class. I'm going to meet you in the next session. Until that, keep learning, keep on growing. Thank you very much.